In this video, I'm going to give you a very brief introduction to synaptic transmission up to the point when neurotransmitter is released from the synaptic terminal. So then, we start off with a synaptic terminal represented like this. We need to add some sodium-ion channels and, of course, some potassium channels. So now, as an action potential arrives towards the synapse, sodium channels are activated in turn to propagate the action potential. But when it gets to the terminal, we don't have sodium channels, but instead we have calcium channels. Because there's no sodium channels here, the action potential is actively propagated, but the synaptic bouton is small enough for that not to be a problem. So as the depolarization and the action potential reaches the calcium channels, this results in the calcium channels opening and calcium entering the cell. Now remember that normally intracellular calcium is very low, usually in the submicromolar, well really in the nanomolar range, but the result of the influx of calcium is that this calcium level suddenly rises. Now, before all this was going on, there were vesicles of neurotransmitter present in the terminal, and the sudden rise in intracellular calcium causes them to fuse with the membrane. And this means that now the inside of the vesicles is continuous with the outside of the cell, and so the neurotransmitter is released and so diffuses out into the gap between the presynaptic and the postsynaptic cell.